So, good morning, children. Today's class will be the last class for limits. Okay. So, here we have left hand limits and right hand limits. This I explained in the first period or second period. So, we have like this: left limit is denoted by a minus, right limit is denoted by a plus, f of x tending to a minus a plus. Like I explained this, suppose you have the number 3. Suppose x is tending to 3. No, suppose that x is tending to 3, then left side values are the values less than 3. That means 2.9, 2.99, like that. Right side values of 3 are the numbers which are very nearer to 3 but greater than 3. That is like 3.001, like that. So x is approaching 3. X tending to 3 means x is approaching 3. From left side values means from values less than 3. So that is denoted by x tending to 3 minus of f of x. So this definition this is the definition given. We mostly will not be using that. So this is the definition. Now when x is approaching 3 from values greater than 3, then it is called as the right hand limit, and it is denoted by x tending to 3 plus, limit x tending to 3 plus of f of x, which is limit h tending to 0 of f of 3 plus h. When it is left hand limit, you must write 3 minus h, like that. So that is the actual definition. So when from left side and from right side it approaches the same value, then we say that the limit value exists. That means when limit x tending to a minus of f of x is same as limit x tending to a plus of f of x. When left hand limit is same as the right hand limit, and if it is equal to some L, then we say that limit x tending to a of f of x is equal to L. If these two are existing, but if they are not equal, then we say that the limit does not exist. Limit does not exist, it does not mean that it is infinity. Infinity is a defined value. Limit value is equal to infinity is existing. It is not that. Even it is not even infinity. You cannot define. You cannot say that the limit x tending to a of f of x is equal to some number. Okay, so that is how we define. Limit does not exist means it is not infinity. Infinity is a defined limit. In some problems we got limit value as infinity, no? So the limit is existing and it is equal to infinity, undefined, it is infinity. But here the limit does not exist. If they are not equal, if the left limit is not equal to right limit, then the limit does not exist. Now we'll come across some problems, some functions like this. In x is less than 1 equal to 1, the function is x square. When it is between 1 and 2, it is x. When it is between greater than 2, it is x minus 2. So that means when you take the graph like this, suppose this is 1 and this is 2. When x is less than 2, it is a parabola like this. Some curve you will get. Till 1 you will get like this. And then between 1 and 2, it is a straight line. Between 1 and 2, it is a line passing through origin. So it is a line like this. Between 1 and 2, it is a line like this. Okay. And then between greater than 2, it is a line y minus 3. So it may be a line like this. It may be some line like this, some line. So a function is defined in different intervals in a different way. Between when it is less than 1 means minus infinity to 1, it is a curve, x square, no, so it is a curve. It is y is equal to x square. Between 1 and 2, it is y is equal to x, this is y. And between when it is greater than 2, it is y is equal to x minus 3. So like this the function is defined in different intervals. So if from left side and right side, if it approaches the same number, then we say that the limit exists. Suppose that from it, the function is going like this. Here it is good. it is approaching some number here, and here it is from left side it is approaching some number here, from right side it is approaching some number. So that means the limits values are not equal, so the limit does not exist. So like that we do. Here we should check whether left limit and right limit are same or not. So the questions are like this for these problems. Okay, the questions are like this. Exercise 8b, all these are exercise 8b problems. If find left hand limit and right hand limit at a point, at the point A. He has mentioned the point A, and check whether the functions have limits at that A. So for this particular problem, he has given A as equal to 2. A as equal to 2. So at 2, you must find out whether the limit exists or not. Okay. So now these are the steps. First problem, find left hand at the point A and check whether, okay, question is like this, and check whether the function has limit at those A's, whatever A's are given. So here A is 2. So what we do is we'll write left hand limit. So left hand limit. So what is the left hand limit? Limit x tending to 2 minus of f of x. 2 minus means less than 2. Values less than 2. It takes the values less than 2. Less than 2 but nearer to 2. X tending to 2 minus means it takes the values less than 2 but very nearer to 2. So here it is in this interval. So here it is less than 2 and nearer to 2 means 1.99. They're all there in this interval only. So you must take the function definition as x. So it is limit x tending to 2 minus of x. 2 minus of our function value is x here. Okay, now use this definition. What is it? Limit h tending to 0 of x. In the place of x, what should I write? A minus h. What is A? 2. So I should write 2 minus h. So substitute h as 0. So the limit value is 2. Like that. Okay, now we'll take right hand limit. What is the right hand limit? Right hand limit, I'll write here. Right hand limit. So right hand limit is equal to limit x tending to a plus 2 plus, yes, x tending to 2 plus of f of x. 2 plus means it takes the values nearer to 2 but greater than 2. Nearer to 2 but greater than 2 means it is this. I should take this definition. So it is equal to limit x tending to 2 plus of f of x now is x minus 3. X minus 3. So how it is defined in that particular value? You should take that definition of the function. Take that definition of the function. So limit x tending to, now we will convert it to h tending to 0 of x. I should write as a plus h. So 2 plus h minus 3. A plus h, a minus h. So here we'll write a minus h. Here we'll write a plus h. X will write as a plus h. A is 2. So 2 plus h. Now put h as 0. Then what is this? 2 plus 0 minus 3. That is minus 1. Now are these two values equal? No. This is equal to minus 1. So we'll write left hand limit. Left hand limit is not equal to right hand limit. Therefore, limit x tending to 2 of f of x does not exist. So you should say does not exist, not infinity. It does not exist. You cannot find its value. So left limit is found like this, right limit is found like this. So according to the number given, you should choose what the function is, how it is defined. That function you should write. So, okay. Now next, the question is same. I'm just erasing the question is same. So find the left hand limit, right hand limit, and Okay, next problem. Find f of x is equal to 1 if x is less than 0, and 2x plus 1 if 0 less than or equal to x less than 1. 3x if x is greater than 1. And here a is equal to 1. You can try this problem. You can take it as homework. So you can find the left limit. Left side of a is 2x plus 1. Right side of a is 3. So 3 and 3, the limit exists. You can try this problem. Same as the earlier problem. Limit exists, and the limit answer is limit x tending to 1 of f of x is equal to 3. So left hand limit is equal to right hand limit is equal to 3. You will get. You can try same type of problem. You can try all these problems. Second one, next third one also you can try. F of x is equal to 1 minus x, 1 plus x. If x is less than or equal to 1, if x is greater than 1, a is equal to 1. The answer is left hand limit is 2, right hand limit is 0. So the limit answer, the limit x tending to 1 of f of x does not exist. Does not exist. That is the answer. You can try this problem. Same left limit, you can see left limit is 1 minus 1, 0. Right limit is 1 plus 1, 2. Fourth problem. 1, 2, 3, 0. Next, f of x is equal to x plus 2 and then x square if minus 1 less than x less than or equal to 3, and if 3 less than x less than 5. You must find that a is equal to 3. So the answer is, again see, left hand limit is 1, the right hand limit is 5, and the limit extending to 3 of f of x does not exist. Does not exist. So you can try this problem. Then f of x is equal to x by 2 if x is greater than less than 2, and then x square by 3 if x is greater than or equal to 2, a is equal to 2, and here the answer is left hand limit is 4 by 3, right hand limit is 1, and again limit extending to 2 of f of x does not exist. F of x does not exist. You can try these problems. They are almost the same as the problem which I solved. Same, take the definition. Okay, now we'll do the most important problems. Okay. So most important problem. Show that. Then okay, first problem. Okay, second problem. Show that this problem is very very important. Show that limit x tending to 0 plus of mod x by x is equal to 1, and limit x tending to 0 minus of mod x by x is equal to minus 1. Okay, so now in the solution we'll do like this. You already know the steps. Limit x tending to 0 plus of mod x by x, okay, is equal to limit x tending to 0 plus of mod x. What is mod x? X tends to 0 plus means what? X is greater than 0. X is greater than 0. So what is mod x? Is x. According to the definition, when x is positive, mod x is x only. So we should remove this modulus. So what is mod x? X. So x by x will write. So that is equal to 1. So limit x tending to 0 plus of 1. Limit of any constant number is that constant only. Because of all this. So you will write like this. So it is equal to 1. So like this you have to do. These steps are very important. Okay. Now next limit. This is first bit like. Now limit x tending to 0 minus of mod x by x. Mod x by x. When it is 0 minus, x tends to 0 minus means what? X is less than 0. When x is less than 0, what is the definition of mod x? Mod x is minus x. So we'll write this as limit x tending to 0 minus of minus x by x. So x gets cancelled. So it is limit x tending to 0 minus of just minus 1. For constant, the limit is minus 1. So because of this, these steps you should write, and this part is very simple. So now we'll write is equal to, So you can see the left limit is not equal to right limit. Since limit x tending to 0 plus of mod x by x is not equal to limit x tending to 0 minus of mod x by x. These two limits are not equal. One is plus 1, another one is minus 1. Therefore, limit x tending to 0 of mod x by x does not exist. Mod x by x does not exist. So, like this, we do the problem. Okay, next problem. So, this problem is very important. Okay, next problem. Okay, next problem. This is again very important. Show that. Third problem. Show that limit x tending to 2 minus of mod of x minus 2 by x minus 2 is equal to minus 1. So here you are given x tends to 2 minus means what? In the solution we'll write x tends to 2 minus means x is less than 2. When x is less than 2, x minus 2 is less than 0. Bring 2 to this side. So x minus 2 is less than 0. So what is mod x minus 2? This is negative. Inside it is negative. So this is minus of x minus 2. It is because it is negative. When x is negative, mod x is minus x. In the place of x you have x minus 2. So it is minus of x minus 2 like that. So therefore these steps are important. So therefore limit x tending to 2 minus of mod x minus 2 by x minus 2 is equal to limit x tending to 2 minus of x minus 2. You remove the modulus. So its value is minus of. So by x minus 2. So you can see it is limit x tending to 2 minus of minus 1. Limit of the constant number is that number only. So it is minus 1. That is how we do this problem. Okay, next problem is again very, very important. Show that fourth problem. Show that limit x tending to 0 plus of 2 into mod x by x plus 1 is equal to 3. That is the problem. So here we'll, as we did in the earlier problems, we'll write x tends to 0 plus means what? X is greater than 0. So that means mod x is x. Mod x value is x only. So these are very important problems. in this left limit and right limit problems, you get this type of problems only in the exam. X tends to 0 plus of 2 mod x by x plus 1. Okay. So this is equal to limit x tending to 0 plus of 2 into mod x is x only, no? So 2x by x plus 1 plus 1. So that means limit x tending to 0 plus of 2 plus x plus 1. Now to remove this 0 plus, we should write limit h tending to 0 of 2 plus a plus h, no? So a plus h plus 1. Now put h as 0. Here x is h greater than 0, like that. So this is 2 plus 1, 3. So the answer is 3. So like this we do. Or directly when you substitute x as 0, that is also okay. You can write. Okay, next problem. That is again very, very important. This problem. Step function problem is again very, very important. Okay, compute. The question is compute limit x tending to 2 plus of step x plus x and limit x tending to 2 minus. This problem is very important and very easy problem. Step x plus x. So you know what is the step function? Greatest integer function. So we know that step x is the greatest integer function. So it is the greatest integer less than or equal to x. So now x tends to 2 plus means what? X is greater than 2. X is greater than 2 means x takes the values 2.1, 2 point something like that. X is nearer to 2 but greater than 2. So that means what is step x value? Its value is just 2 only. Because what is the greatest integer nearer to 2? 2 only. Okay. Now x tends to 2 minus means what? X is less than 2. When x is less than 2, what is the greatest integer less than 2? That is 1. So step x function, step x value will be different when you take the real number line, add to 2. When it is less than 2, step x value is 1. When it is greater than 2 and nearer to 2, its value is 2. So these two things we should observe and just write the limits. So first bit, limit x tending to 2 plus of step x plus x. So that is limit x tending to 2 plus of, like how we remove the modulus. Here also we should remove this step function bracket and we should write its value. X tends to 2 plus, no? So it is 2. So 2 plus x. 2 plus x. So it is equal to limit x tending to h tending to 0 of h tending to 0 and h is greater than 0 of 2 plus h. A plus h I should write. A plus h. A is 2. 2 plus h. So the answer is 4. So it is equal to 4. This is the left hand limit. Substitute h as 0. So when you substitute h as 0, it is 2 plus 0. That is 4. Okay, 4. Now we'll take the second bit. Limit x tending to 2 minus of step x plus x. X tending to 2 minus of step x plus x. So when it is 2 minus, step x value, bracket value is 1. So it is limit x tending to 2 minus of 1 plus x. Its value is now 1. So now substitute, so 1 plus x. For 1 plus x, we will write limit h tending to 0 of h is less than 0 of 1 plus 2 minus h. A minus h you should substitute. So it is equal to 1 plus 2 minus 0. That is 3. So left limit is 3, right limit is 4. So you can say that he didn't ask, we can conclude. Since left hand limit is not equal to right hand limit. The limit extending to 2 of step x plus x. This is not asked in the question, but step x plus x does not exist. Only these two he asked. But because we observed that the left limit and right limit are not equal, we are concluding like this. Okay. Okay, we solved almost all important problems. Okay, this problem is very, very important. Okay, now we'll do one more problem. If f of x is equal to, still we have time, f of x is equal to x square and then 2x minus 1 when x is less than or equal to 1, x is greater than 1, find limit x tending to 1 plus of f of x and limit x tending to 1 minus of f of x. And then does limit x tending to 1 f of x exists? That is the question. So it is almost the same type of problem. Okay, you can just try these problems. One more problem. Okay, in the solution, we'll write limit x tending to 1 plus of f of x. So first we'll write the function. In the answer, we'll write let f of x is equal to, has given f of x is equal to x square, x less than or equal to 1, 2x minus 1, x is greater than 1. We'll do like this. These are the steps. So therefore, limit x tending to 1 plus of f of x. 1 plus means it is x greater than 1. 1 plus. When x is greater than 1, I should write 2x minus 1. So I should write 2x minus 1. So 1 plus. So I should change h tending to 0 of h is greater than 0. 2 into 1 plus h minus 1. Now substitute h as 0. So 2 minus 1. 2 minus 1, that is 1. So the left limit is 1. Now we'll find the right limit. Right limit is 1. Now we'll find the left limit. 1 minus. When it is less than 1, what is the function? X square. So I should write limit x tending to 1 minus of x square. So that is limit x h tending to 0 of h tending to 0, h is less than 0 of 1 minus h whole square. That is also 1. So, okay, they are equal, no? Left hand limit. So limit x tending to 1 plus of f of x is same as limit x tending to 1 minus of f of x, which is equal to 1. Implies that limit x tending to 1 of f of x exists. It is existing because both are equal. Does this limit exist? So exists and is equal to 1. And it is equal to 1. So like this, we do the problem. So the limits chapter is very important chapter, and these are the basics, first basics that you have to learn in calculus. So using these limits, we find the derivatives. The next chapter is based on these limits only. So we'll write the derivative of a function. Derivative of a function f dash x we'll write. That is defined as limit h tending to 0 of f of x plus h minus f of x by h. So it is almost a continuation of this limits only in derivatives. So there you have many formulae you have to learn, and using those formulae you will do the problems. But starting it is again based on this limits only. So you just understand and practice all these problems, these methods. These we need again in differentiation chapter. Okay. So with this we completed limits chapter. Okay. Thank you.